With exponents, what's important with it is that you know your laws very well, okay? So the very first law of exponent goes like this. If you have a to the power of maybe n multiply by a to the power of m, this will then be equals to a to the power of n plus m. Remember, a can be any number, n can be any number, m can be any number. So recognize here between these two terms, it's multiplication. So that means this law only applies to a multiplication. And then recognize that the first term has a base a and the second term has a base a. So both of them have the same base. So what the law is saying is that if you are multiplying two terms that have the same base, then you can add their exponents. So the second law will be anything to the power of 0 gives us a 1. It doesn't matter if it's 100 to the power of 0, or we can have a, b, c. So long as all that a, b, c is to the power of 0, the answer will be equals to 1. And then another law is that if you have a to the power of minus 1, this becomes 1 over a. So that's how we make an exponent a positive. So this can translate into, let's say we have a to the power of minus 2. We can make this 1 over a squared. We just say 1 over. This negative becomes a 1 over. Then the exponent becomes positive. Another law of exponent is if now you have same bases with different exponents and then it's a division in between your terms, then what will then happen? It's going to be base a, then we subtract the exponents. Remember, if it was a multiplication, we added the exponents. Now that it's a division, we subtract the exponents. Remember, this only applies if it's a division. All right, for sets or roots, so that will be something that is inside either a square root, let's say the square root a, or we can have a cube root of a, or it can be any number really. Let's just say n. Okay, so how does this transfer into or translate into? If there is no number inside the outside of that root there, then we know that it's a 2. But remember, if it's a 2, then we don't write it down. So how do I break it from being a set to being an exponent form? So we're now going to say a to the power of, it's to the power of 1 there. Remember, we won't write that 1 as well. But we should know if there's nothing there, it is to the power of 1. So we take the exponent that is inside over the one that is outside. If there's nothing outside, automatically we know that it's a 2. So square root of a in an exponent form is a to the power of 1 over 2. How about this one here? In an exponent form, this would be a to the power of, what if there's no number there? Then we know it's a 1 over what's outside, then it's a 3. So that means a cube root of a in an exponent form is a to the power of 1 over 3. And then let's say here we have a to the power of m. How do we make this in an exponent form? So this will be then a to the power of m, which is inside, over the number that is outside. So that's how we transfer sets to exponential forms, and you can also always convert your exponential forms back to set form in a similar manner. So this first exercise, we will be able to solve it using that first law. Because what we recognize is that with this here, we have two terms with the same base y, and then the other one has exponent 3, the other one exponent 3. And then this also, it has the bases y with exponent 2 as well as 4. Do recognize that that law doesn't apply for that plus there because it was only for a multiplication. So for this first term, what do we know from that first law? We take the base. That only works if the base is the same. So we see that the base is the same in this case, which is a y. So what we do when the base is the same with multiplication in between, then we know we add the exponents. So it's going to be y to the power of 3 plus 3. And this side, we will have y to the power of 2 plus 4. Okay. And then we will end up with y to the power of 6 plus y to the power of 6. So now we have terms that look exactly the same. And then y to the power of 6 plus y to the power of 6. 2y to the power of 6. All right, let's now apply those three laws to the following exercise. All right, we notice that we have multiplication, so we're going to look for the bases that are the same. All right, so what then do we have? If we apply that, we can have a, it's multiplication in between. So that means we're going to add the exponents. So this will be 3 plus minus 3 plus a 0. And then the constants here, we can just treat them separately as 2 times 3 times 4. What we then have is a 24, a to the power of 3 minus a 3, it's a 0. 0 plus 0 is equals to 0. What have we learned about anything to the power of 0? That is equals to 1. So this is the same as 24 multiplied by 1, and the answer will be equals to 24. Or I could have just broken it down to each separate laws from that one there. So I could have said 2a cubed multiplied by 3. And then what do I remember about this law here? I can make this a 1 over. Then that exponent 3 becomes a positive. And then here we will have 4 times, what is a to the power of 0? It's a 1. All right. And then we can come down with it. And then at the on top now, because now there is a denominator that we just created, we can have 2 times 3 times 4, which gives us a 24. And then we have a to the power of 3. And then at the bottom, this denominator that we just created is still a to the power of 3. So a to the power of 3 will be divided into a to the power of 3, and the answer is 24. Whether you did it the first method or this way around, still correct. What's important is that we applied the laws of exponents. So with an exercise like this one, it's very important to know your squares and to recognize them. Okay, immediately what I see there is a 25, and then I know that 25 is 5 squared. I also see a 4, and I know 4 is 2 squared. So those are kind of the things that have to be in your head that you can recognize almost immediately when you see them in any math sum. All right, so let's break this down. So inside here, we have a square root of 5 squared. We know 5 squared is a 25. And then we have a cubed multiplied by square root of 2 squared, a squared. Okay, so applying our laws of exponents, this is the same as 5 to the power of 2 over, if we know that if we don't have anything outside there, that is a 2. Then we still have a to the power of 3 multiply by 2 to the power of 2 over, what if there's nothing inside there? Then we know it is a 2. All right, so now we have 5 to the power of 2 divided by 2. This is equals to 1. We're still going down with the a cubed. We will end with it. And then we have 2 to the power of 2 divided by 2. 2 divided by 2 is another 1, a squared. All right. So we can say now 5 times 2 is equals to a 10. And then now, again, we recognize that first law of exponents. We have a multiplication in between our terms, and the bases are the same. So that means now we're going to have base a. And then what do we do with the exponents if it's a multiplication in between? We add the exponents. So it's going to be to the power of 3 plus 2. And then this will be equals to 10 a to the power of 5. So remember, we could have just gone straight into square root of 5 multiplied by square root of 4 on the calculator and get to a 10. But what's important in mathematics is going through these steps so that you show that you know your laws of exponents, and then you get your full marks. Okay, this one here, we're still just going to transfer sets and stuff. So I know any decimal I can change into a fraction. Decimals are equivalents of fractions, just like here we have sets are equivalents of exponents. Okay, how do I then make this a fraction? I see that I have a 4 there, so I can say 4 over, okay, the fact that I have 2 zeros before a 4, that makes it over 100. If I had 0.00, that means there are 3 zeros before a 4, it would have been a 4 divided by 1,000. So I was able to divide by 100 because it's 2 zeros before that 4. What if it was just 0.4? Then I would have had a 4 over a 10 because there's just 1 zero before the 4. So just notice 10, 100, 1,000, depending on how many zeros you have before that digit. All right. So now I'm going to break down my things. Immediately I notice that these are squares, a 4 as well as 100. Okay. So I will have the square root of, what is 4 in terms of squares? It's 2 square. And then what is 100 in terms of squares? This is 10 square. And then I'm going to just break everyone up separately. So what do I then have here? I have a to the power of 4 divided, what's outside? There's nothing, so we know that it's a 2. Multiply by b to the power of 2 over what's outside that set or root. There's nothing, though I know that it's a 2. So that means here I am going to have 2 to the power of 2 over 2. Remember, there's nothing outside the root. I'm going to have 10 to the power of 2 over 2. So the 2 took the root, and then the 2 of the 10 that took also the root. And then 4 divided by 2, that's a 2. 2 divided by 2, that is a 1. So what we end up having here, we have 2 to the power of 2 divided by 2. This becomes a 1. So we have 2 over 2 divided by 2. Again, it's another 1. We have 10. A squared b. Remember, the 1 we don't have to write in mathematics. To simplify this even further, I recognize that 2 goes into 2 ones and 2 goes into 10 5 times. So we don't leave a fraction like that. We always have to make sure that we are in a simple form. Okay, how we say 2 divided by 2 gives us a 1, and 10 divided by 2 is a 5. So the answer would then be 1 over 5 a squared b, or we can even say a squared b over 5. I just took this and took it there to the denominator. Whether you leave it in that form or you give an answer in this form, it's correct, so long as you have this fraction in its simplest form and you didn't leave it as 2 over 10. Okay, this is an easy one, that now that we know how to convert sets into exponents, and we know that first rule of exponents. Okay, so let's break this down and make it in an exponential form. This is going to be x to the power of 2 over, what comes on the over, what's outside here. If there's nothing on the outside, then we know it's a 2. Then we say multiply by x to the power of 4 over, there's again nothing outside there, then we know it's over a 2. Okay, so we're going to have x to the power of 2 divided by 2, which is a 1, multiplied by x to the power of 4 over 2, which is a 2. Notice, same base x with a multiplication in between. Then the law says we have to take base x. Because it's a multiplication, then we add the exponents. So this will be x to the power of 1 plus 2, and the answer will be equals to x to the power of 3, or x cubed. This one, we're going to break it again into an exponent form. So we're going to have x minus 1. So that x minus 1, all of it, we treat it as a base because it's inside a bracket. So this will be to the power of 3, this 3, over what's outside. And then what's outside is a 3. Okay, it's always to the power of what's inside over what's outside. Okay, and then we now have the answer as x minus a y. 3 divided by 3 is 1. And we don't have to write that 1 out. All right, lastly, this may look complicated, but not at all. We're just going to break it down into pieces. All right, let's start inside the sets with the first one there. Just recognize that I know a 16, which is a 2 to the power of 4. Okay, and then we still have 2 over 2. So the reason why I made a 16 in a base 2 in an exponential form is because of that 2 there. Okay, then I will just go x3, y3, x3. So I'm just going to try by all means all over to have the same basis. Okay, let's try with the second term there. I'm calling this a term because they are separated by a negative. This makes it a term. Separated by a positive, that means this makes it a whole term. So here we have 3 squared, y4, all over. I can make that an exponential form with base 3. We know that 9 is a 3 squared. Plus this side, 98 is not a perfect square, but I can break it down to 2 multiplied by 49. This gives me a 98, and at least I get that 2 there. So we can say 2 multiplied by 49 y squared over 2. Okay, so let's break the first term down. Okay, I will end with the set forms. So inside here, I know that this law says if the bases are the same with a division in between, subtract the exponents. So that's what I see with the first one here. I see a base 2, one to the power of 4, the other to the power of 1, with a division in between. So what am I going to do? I'm going to take this 2 and I subtract the exponents, which is 4 minus 1. How about an x? Same story. So the base is x. The exponents are 3 and 3, so it's going to be 3 minus 3 because there's a division between the two. And then lastly, we have y cubed. Okay, minus the second term, same story. I recognize that I have two things with same base 3 and there's a division in between. So that will be base 3 to the power of 2 minus this 2 here, y to the power of 4 plus this side, we might as well just say 2 divided by 2 and then they disappear. So what I know 49 to be, it's a 7 squared, then we have our y squared. So now we're going to go and break those sets and make everything in an exponential form. Let's start with the 2 here. We have 2 to the power of 4 minus 1 gives us a 3 over 4 minus 1 gives us this 3 over what's outside. It's over 3. Let's go for the x. This gives us x to the power of 3 minus 3. That's a 0 over 3. And then for the y to the power of 3 over what's outside, a 3. Okay, and then for the second term, we break in this set. Remember, if there's nothing outside, then there's a 2. So we're going to have 3 to the power of 2 minus 2. That's a 0 divided by what's outside. It's a 2. And then y to the power of 4 over what's outside. That is a 2. And then the last term, we have 7 to the power of 2 over what's outside, a 2. Y to the power of 2 over what's outside, it's a 2. If there's nothing outside, then it's a 2. Okay, now simplification, we're going to have 2 to the power of 3 over 3. That's a 1. We don't have to write it down. And then we have x to the power of 0 divided by 3. It's a 0. Y to the power of 3 divided by 3. It's a 1. We don't have to write it down. Then we have 3 to the power of 0 divided by 0 is by 2. It's a 0. Y 4 divided by 2 is a 2 plus 7. 2 divided by 2, it's a 1. Y 2 divided by 2 is a 1. We don't have to write the 1 down. And then we recognize to the power of zeros. And we know that anything to the power of 0 is a 1. So this is a 1. This 3 to the power of 0 is a 1. So this now goes down to 2 times this 1 times y will give us a y. Minus 1 times y squared gives us a y squared. And then we have plus 7y. Do notice that we have like terms here because both of them are to the power of 1. So 2y's plus 7y's make it 9y minus y squared. That will be your answer.